Okay children, so today we are going to start the chapter Atomic Structure and Chemical Bonding of your Standard 9 ICSE board. So as you can see from the title itself, the chapter is broadly divided into the structure of an atom, that's your atomic structure, and how these atoms combine to form a bond or to form new molecules. That's your part of your chemical bonding. Now what do we know about atoms? Atoms are the building blocks of matter. Atoms are something which combine many atoms, millions of atoms come together and form an element. What is an element? Element is a pure substance which is made up of many atoms which look alike, which are identical to each other. So we can say that atoms are the building blocks of an element. We already know this. So the word atom, as we know it, it was first mentioned by Maharshi Kannad. He used the word Parmanu for an atom and Anu, a molecule. Later on, Democritus also mentioned the word atom. Atom, according to him, meant that a substance which is indestructible or it is indivisible. What does it mean to be indestructible? That means it cannot be destroyed. What does it mean to be indivisible? That it cannot be further divided into smaller parts. The first scientist who actually studied the characteristics of an atom, this was in the early 1800s, was Dalton. Dalton said that matter consists of small and indivisible particles. These particles are called as atoms. So atoms are, according to Dalton, atoms are the smallest part of an element. This is something we have been also studying for a very long time. Atoms cannot be created nor be destroyed. So atoms, since he said that atoms are indivisible and indestructible, so that they cannot be created, they cannot be destroyed. In a way that he is saying that atoms are indestructible. Dalton also said a very important observation. Dalton said that atoms of a single element are all alike. So if we are talking about element like copper, all atoms of copper are going to be alike, and atoms of different elements are different in every way. So if I have to compare atoms of copper and atoms of carbon, they are going to be different in every way. So it is a way to say that all atoms of copper are alike, all atoms of carbon are also alike, and all atoms of copper are very different from all atoms of carbon, and likewise. So atoms of the same element are alike in every way, and atoms of different elements are different in every way. And another very important observation which we still use, that atoms of an element participates in chemical reaction, and atoms of an element combine with atoms of other element in simple ratios to form new matter or new compounds or new molecules. This is something which we still use. This is a theory which is still valid and universal. So if you see an example of water molecule, water is H2O. So if two atoms of hydrogen combines with one atom of oxygen, it gives me one molecule of water which also contains two atoms of hydrogen and one atom of oxygen. So we can see that they are combining with each other in a simple ratio. 2 of hydrogen combines with 1 of oxygen to give me one molecule of water which contains 2 atoms of hydrogen and 1 atom of oxygen. So this is something we still find to be valid. Many of his theories are invalidated right now. We will talk about them, but let us do a quick recap first and see what is Dalton's model of an atom. Are the smallest and the most indivisible part of an element. He said that atoms can neither be created nor be destroyed, and atoms of a single element, of the same element, are alike in every way, and those atoms are different from the atoms of other elements. So atoms of same elements are alike, and atoms of different elements are different from each other. They are not alike. Atoms combine with other atoms in simple ratios and participate in chemical reactions. Now with the advancement of science and technology, we are talking about Dalton in early 1800s. Now we know that there are 200 subatomic particles. We know that atoms can be destroyed. So when we talk about nuclear fission, a big atom is destroyed and it forms two smaller atoms. So atoms can be destroyed. Now we also know of the existence of isotopes. We will be studying about that in this chapter briefly. So what are isotopes? Isotopes are atoms of same element, but they do have some different attributes. They are not exactly alike. So like Dalton said that atoms of all elements are alike, that is also not entirely true. But when Dalton said that elements participate in simple ratios in chemical reactions, or atoms participate in simple ratios in chemical reactions, he was right. Now, after this brief study about an atom, William Crookes, a few decades after Dalton, William Crookes studied some characteristics of atoms of a gas. He used an equipment called as the discharge tube. What is a discharge tube? In simple words, a discharge tube is a equipment which is made of a glass tube, which is usually connected to electric current or magnetic field or both, and it is mainly used to study the nature of gases or how gases behave in the presence of electrical field or magnetic field. So William Crookes used a discharge tube and he emitted some rays from the cathode, or which is the negatively charged terminal, and he called it a cathode ray or cathode rays. When he studied these particles, when he put it in a discharge tube, he observed that these rays are traveling towards the positively charged terminal. Later, when he introduced an electric field near this discharge tube, he saw that these particles are attracted to the positive plate of the electric terminal. When he made the same observation using a magnetic field, he saw that these particles are behaving just like how negatively charged particles behave. In the electric field also he saw that these particles are traveling towards or getting pulled towards the positive terminal. So which particles get attracted to positive particles or positive terminals? Opposites attract. So negatively charged particles get attracted to the positive terminal of the electric cell or to the positive terminal of the discharge tube. So he observed that these cathode rays, which were later, now as we know cathode rays are nothing but electrons, beams of electrons moving at very high speed. So these cathode rays showed properties which were similar to negatively charged particles. So he observed that when these gases, these atoms of the gases are under a condition of very high voltage and very low pressure inside a discharge tube, one component of this gas was attracted to the positively charged terminal or positive plate of the electric field. So these particles came to be known as electrons, and electrons are the particles which are present inside an atom, because he studied gases, and gases are elements, and these elements, gases like nitrogen, oxygen, hydrogen, they are made up of elements. The gases that he studied in his discharge tube are made up of elements, and these elements are made up of atoms, correct? And a part of this atom is attracted to the positive terminal, and that part of the atom is an electron. So atoms contain negatively charged particles, and these particles were later called as electrons. Let us look at some of the characteristics, some of the properties of an electron. So like I told you, cathode rays are basically nothing but electron beams, electrons moving at a very high speed. Electrons are an integral part of every atom. Like I told you, these gases contains atoms, and these atoms contains electrons which gets attracted to the positive terminal. This electron is independent of whichever gas I use in the discharge tube. That means if I use hydrogen gas or if I use oxygen gas, I could use any gas, but this property of the electron being a negatively charged particle does not change. It does not depend on the gases. Looking at the mass of an electron, is a very light particle. So if you compare it to the mass of hydrogen atom, it is 1 by 1837. So it is almost 1837 times smaller than a hydrogen atom. It is a very small particle. It's a very light particle. We can say the mass of an electron is somewhat around 9.108 into 10 to the power minus 28 grams. It's a very light particle. Talking about the charge, we know that electrons are negatively charged. That's why they got attracted to the positive terminal of the electrode or the electric plate. It got attracted to the positive terminal. But what is the exact charge? What is the magnitude of the charge? The magnitude of the charge is minus, because it's negatively charged particle, it's minus 1.6 into 10 to the power minus 19 coulomb. So this is the charge of each electron. What will be the charge of one electron? Minus 1.6 into 10 to the power minus 19 coulomb. When we come to the radius of an electron is very small. It is it's in the lines of 10 to the power minus 15 meters. It is a very small, light, negatively charged particle which is present inside an atom. So how do we denote an electron? The mass is written on top. So mass of an electron, we take it to be negligible, almost negligible. So we write the mass to be equivalent to 0. What about the charge? It is written at the bottom. Charge of an electron, one electron. We do not write the whole magnitude. We say that one electron carries unit negative charge. Unit means 1. So minus 1 charge is carried by each electron. This is for the simplicity of denotion. Otherwise, the magnitude of the charge of each electron is how much? Yes, it's minus 1.6 into 10 to the power minus 90 coulomb. Now, with this ongoing study with the discharge tube and gases in the condition of very high voltage and very low pressures, it was observed by another scientist named Goldstein that when he used a perforated anode. Now what is an anode? Anode is a positively charged terminal of the discharge tube. So when he used a perforated anode, he saw that cathode might be traveling towards the positively charged terminal, but there is some other particle which travels towards the negatively charged terminal. So he found that there are some particles in this atom of the gas which also travels towards the negative terminal. That means they are attracted to the negative terminal. That means that their charge should be positive. These positively charged particles were later called as protons. But what did Goldstein observe? He made this observation based on the idea that atom is neutral. Atom does not have any charge, but if it has electrons, if there is a presence of a negatively charged particle, there also has to be a presence of positively charged particle of same magnitude. Only then they can cancel out each other, only then they can neutralize each other, and hence an atom does not have any charge. You can't just have negatively charged particles inside an atom and still be neutral. That's not possible. So this experiment with a perforated anode was conducted, and it was successfully seen that there are indeed positively charged particles, and these positively charged particles move towards the negative terminal or the cathode of the discharge tube. Now these positively charged particles were called as protons. These protons are also an integral part of an atom. That means an atom contains electrons which are also integral part and protons which is also now an integral part. So this was a very path-breaking discovery. Why? Because now you could tell that the presence of two subatomic particles led to an atom to be electrically neutral. So after this experiment that was conducted by Goldstein, he also could make certain observations about the characteristics of this proton. So protons are also an integral part of every atom. Just like electrons, protons are also present inside an atom. Protons also do not really exhibit their characteristics based on which gas is used. It is completely independent of the characteristics of the gas, whichever gas may be used. If the conditions are that the voltage is high and the pressure is low inside a discharge tube, you will observe protons, and all protons are going to be alike. Talking about the charge of a proton, obviously it moves towards the negative terminal or the cathode. So the protons must be positively charged. So what should be the magnitude of their charge? The magnitude of charge of each proton is 1.6 into 10 to the power minus 19 coulomb. The magnitude of charge of each electron was how much? Minus 1.6 into 10 to the power minus 19 coulomb. So can we say that protons and electrons have the same charge? That means the same value, numerical value of the charge, but they are opposite in nature. So electrons has negative charge and proton has positive charge of the same magnitude. Talking about the mass of a proton is much larger as compared to the mass of an electron. Mass of an electron was somewhere in the lines of 9.1 into 10 to the power minus 28 gram. Mass of a proton is somewhere around 10 to the power minus 24 gram. The mass is 1.6 into 10 to the power minus 24 gram. So what is the difference? The difference in the number does not matter. The difference in the index matters. 10 to the power minus 28 is much smaller than 10 to the power minus 24 grams. So there is a big difference between the mass of protons and the mass of electrons. Talking about the denotation of proton, proton again same as electron, mass is written on top and charge is written in the bottom. Now we can say that unlike electrons, protons do have mass. So we assume that the mass of each proton is unit mass. That is, each proton carries mass of 1 atomic mass unit. We will come to the units later, but instead of using the entire mass of 6 into 10 to the power minus 28 grams, we say each proton contains a mass of 1 unit. And what is the charge? The charge of an electron was minus 1 unit negative charge. So the charge of a proton is plus 1 unit positive charge. Now that the discovery of protons and electrons are done, now we have discovered protons as well as electrons, they have opposing charges. So now we could come up with a theory. The theory was given as a plum pudding model by J.J. Thomson. Sir J.J. Thomson gave us the watermelon model or the plum pudding model. What does it really mean? So if you have seen a watermelon, watermelon has a flesh, a red color flesh, and it has seeds which are black in color. So he said that just like a watermelon, the flesh of the watermelon is the positive charge and the seeds inside a watermelon were the discrete negative charges provided by the electrons. So what he actually said was that protons or the positive charge is spread all around the atom, and so the entire flesh or the entire body or the entire volume of the atom is made of positive charge, and there are small particles of negative charge which are the electrons, which are placed like seed, or you can say the entire cake is a positively charged, and the particles which are the plum particles which are in this pudding or in this cake are comprising of negative charge. So, and in this model that he gave, the plum pudding model or you can say the watermelon model, both mean the same thing. In this model, he made a very important observation that the net positive charge, the total positive charge which is present due to the protons, any number of protons in the pudding, is equal to the total negative charge which is present due to the same number of electrons in the shape of plum. So the net positive charge is equal to the net negative charge, or the total magnitude of negative charge and positive charge are equal. So if I take away one seed from this watermelon or one plum from this pudding, what will be the charge of the remaining pudding or the remaining watermelon? The charge will be positive. So this plum pudding model given by Thomson was soon challenged by Lord Rutherford. Lord Rutherford conducted an experiment. This experiment is called as a gold foil experiment. What did he do in this gold foil experiment? He took alpha particle. Now what is an alpha particle? It is a particle which has double positive charge. So a proton has one positive charge and alpha particle has 2 units of positive charge. So he took alpha particles and he bombarded those alpha particles on a very thin sheet of gold, and he made certain observations. Before looking at the observations, let us see experimentally how did the gold foil experiment look like. So if we can look at this model that I have presented here, we can see 2 layers of atoms. So it's a very thin gold foil. We can only see 2 layers of atoms of gold present inside this foil. So when he bombarded this with many alpha particles, so he observed that most of these alpha particles are going undeviated. Some of these alpha particles are making a small deviation, and very few alpha particles are getting deflected backwards in its path. So what does this observation tell us? Let us analyze before understanding what was said by Lord Rutherford. So we know that this gold foil is getting bombarded by a particle called as alpha particle. And what is the speciality of this alpha particle? This alpha particle has 2 positive charge. So it's a positively charged body, can I say that? So this positively charged body is moving through an atom, the atoms of gold. It's moving through an atom without any resistance. It is just flowing through the atom without any resistance. So how can a positively charged body move through a space without any resistance? Either the space have to have no charge, it has no charge, so it's moving with the same speed. But we observe some accelerated speed. The speed actually increased. So what could be the reason for this acceleration? The presence of an opposite charge. So when an opposite charge is present, it pulls the positive charge. So if a negative charge is present inside the gold foil, it will pull the positively charged alpha particle towards itself, and it will allow the free flow and accelerated flow of those alpha particles. Since most of these alpha particles went undeviated, we can say a lot of the space of this atom. Which atom? The atom of gold, the atoms of gold. A lot of the space of this atom is negatively charged because the alpha particle went undeviated. We observed some of the alpha particles just slightly deflected. Slight deflection could be because of a presence of a like charge. So if positive charge come close to each other, they push each other away from away. So sometimes when these alpha particles were close to a positive charge, close, not entirely head on, close to a positive charge, it got slightly deflected away from that positive charge. And he also observed very few complete head-on deflection. That means the alpha particle almost retraced a back path. When can that happen? When it comes head-on with a positive charge. That means at very few instances there is a positive charge that is present in a very small space of the atom. There is a positive charge which is present, which is accumulated, which deflects these positively charged alpha particles and makes them retrace their path. So what are the observations that we can make based on this model. Let us look at the observations that were made by Lord Rutherford. So Rutherford gave us the first very modern looking model of an atom. He said that nucleus of an atom is centrally located. Nucleus is the name that was given by him. He said this nucleus is the only part that carries positive charge, because we observed that very few were deflected and even fewer were completely retracing their own path. So positive charge repelling another positive charge is happening at very few instances. So the presence of the positive charge is central. It is present in a very small space, and this space was called as a nucleus by Lord Rutherford. Moving on, the entire mass was also seen to be observed to be at the center. And what is the center? The center is nucleus. So entire positive charge and the entire mass is present inside this nucleus, which occupies very little space but very high mass. It was also shown by him that most of the alpha particles went undeviated. That means they passed through a negatively charged space. They passed through a space which was negatively charged, which allowed the alpha particles to move freely and even maybe be accelerated. Alright, because they are pulling the alpha particles towards themselves. So based on this, Rutherford said that nucleus is at the center, mass is also in the center, positive charge is also in the center, and the electrons revolve around whom? The nucleus, like planets revolve around the sun. So this was his observation, and this was called as the planetary model of Rutherford. This is a very modern way to look at our atom. So now we could imagine an atom to be just like our solar system. The sun is at the center, and in cases of atom, what did we see? That the positive charge and the mass is at the center. In the planetary system, the planets revolve around this center, and in the atomic system, electrons revolve around this center. So it was a very acceptable model of an atom. But on closer observation, we see that planets are not really charged particles, but positively charged nucleus has a charge, electrons also have a charge, and it is known that when a charged particle moves in space, anywhere in space, in any direction, in any type of motion, it loses some energy. And when it loses that energy, that planet will slowly lose little energy and spiral towards the sun. Or basing this on our atomic model, that electron will slowly lose its energy and collapse into the center or the nucleus. But none of that happened. We did not see any instance of an electron collapsing into the nucleus. So Niels Bohr came up with an actual electronic or orbit model. He said that the positive charge and the mass is accumulated at the center of an atom. The electrons revolve around the atom in a fixed distance, at a fixed distance that never changes. There is no loss of any energy, and hence these fixed orbits were now called as shells. Like Rutherford said, the electrons revolve around in orbits. Bohr gave a new name to this orbit. He called them energy levels. What does it mean to have a certain energy level? It means that the electrons will revolve around the positively charged nucleus at a fixed distance, and this fixed distance orbit will have a fixed amount of energy, and that energy will never change. That means the electron will never collapse towards the center. So this way we could see our modern orbit model, which was given by Niels Bohr, and this model, he also gave a special name to these orbits. What is the special name? Yes, the special name was energy levels. Sometimes these energy levels are also called as shell. And remember one thing, the energy level closest to the nucleus has the least energy, and the energy level which is farthest from the nucleus, so there are many energy levels depending on the number of electrons. So the energy level which was farthest had the highest energy. These were the observations which were made by Bohr. So now it was a well accepted fact that the positive charge and the entire mass is concentrated in the nucleus, and the negatively charged electrons are revolving around in fixed energy levels or fixed orbit around this positively charged nucleus. So now it was a well-known theory that the positive charge and the entire mass of an atom is inside the nucleus, which occupies a very small volume, and the electrons revolve around the nucleus in fixed distance from the nucleus, and these were called as orbits, shells, or very famously energy levels, and energy levels do not change. So for example, when you look at a helium atom, helium contains 2 electrons and 2 protons. So mass of helium should be equivalent to the mass of 2 protons plus 2 electrons, but we have seen that the mass of electrons is negligible as compared to the mass of protons. So by ignoring them, we can say roughly the mass of helium should be equivalent to the mass of 2 protons. But when it was observed, when it was explained the presence of doubling of the mass, what is the other particle that could be present here that is doubling the mass of the nucleus? So since the mass of the nucleus is getting doubled, there has to be some other subatomic particle which is adding to only the mass and not the charge. So the presence of a particle which only offers its mass, it does not have any charge. Why doesn't it have any charge? Because we know that electrons and protons have the same magnitude of charge with positive sign and negative sign. Electrons are negatively charged, protons are positively charged. We also know that there are same number of electrons and protons contained in an atom, so their charges are neutralized. But since the mass of the atom is much larger, almost double the mass of the total number of protons, this shows the presence of a third particle which does not have any charge but adds to the mass of the atom. This particle was called as neutron. Neutrons do not have a charge. So it was observed that neutrons are also an integral part of an atom. They are a part, very much a part of an atom, just like electrons and protons. Neutrons have a mass which is almost equivalent to the mass of a proton. But you should know that neutrons are a bit heavier than protons. How will you represent a neutron? Neutron is represented again with its mass on top, written on top. So mass is 1, and what about the charge which is written on bottom? Charge is 0. So what does a modern atomic model or a modern orbit model of an atom look like? You have your positive charge in the nucleus, but nucleus also contains other things. It contains neutrons also. So the entire mass and the entire positive charge is in the nucleus. So what does the nucleus contain? All the mass. Who are providing the mass to that atom? Neutrons and protons. And it contains all the positive charge. Who provides positive charge? Protons. So who lives inside a nucleus? Protons and neutrons. Who revolve around the nucleus? Electrons. So Dalton observed an atom to be a small indestructible particle, a solid 3D sphere of some kind. But by the time electrons, protons and neutrons were discovered, now we know that an atom has protons and neutrons in its nucleus, that is the center. Electrons revolve around it in energy levels, energy shells or orbits. Let us do a quick comparison between the historical model and the present model. What is the historical model? Who was the first person to study an atom? Dalton. The orbital model or the modern atomic model. What is the difference between these two? So Dalton said that atoms are indivisible, but now we know that atoms can be further divided into smaller particles. What are these smaller particles? Electrons, protons and neutrons. It's not easy. It's in fact very difficult to separate the subatomic particles, but it's not impossible. Coming to atoms can neither be created nor be destroyed. We know that atoms can be created by nuclear fusion, when two small atoms combine to form a bigger atom of a different element, and atoms can be destroyed by nuclear fission, when a big atom is broken down into atoms of smaller elements and definitely different elements. So this theory is also invalidated. Next, we are talking about atoms of the same element are alike in every way. Atoms of same element are alike in every way, but they are different from the atoms of other elements in every way. So talking about atoms of same elements being alike, atoms of same elements are not alike because some elements have isotopes. What does it mean to have isotopes? Isotopes of an element are those different forms of the same element which has the same number of protons and electrons. They have the same number of protons and electrons, but they have different number of neutrons. Neutrons does not bring any charge, but it does change the physical attributes, the physical quality of that atom. So if hydrogen has 3 isotopes, in the first isotope it has no neutrons, second isotope it has 1 neutron, and the third isotope it has 2 neutrons. All 3 of these atoms are going to be called as hydrogen atoms, because they have the same number of electrons and protons, but their physical properties will be different. And it has been observed that isotopes have same chemical properties because they have same number of electrons and protons, but different physical properties. So this theory was also invalidated. So what is the theory given by Dalton, the first person to study an atom? Which is the one which is still universally accepted? That atoms combine with other atoms and undergo chemical reactions. So this is the first part of our atomic structure chapter. Here we have understood the subatomic particles. How did we discover them? And in the next part of the chapter, we will be studying how these electrons are arranged in these energy levels or in these orbit. And are these electrons exchanged? How are these electrons shared between atoms of two different elements, and a lot more. So to know about them, you should like and subscribe to my channel. Thank you for watching my video.